Hi, and welcome to my video on writing linear algebraic expressions with a single variable. And this is practice 1 part B. Again, some more expressions related to the word problems that you're going to do in the next unit. Write an algebraic expression for each. Let x be the father's present age. So, A, the son's age if 20 years younger than the father. So if the father is X, so the son's age is 20 younger. So it's minus 20. The father's age 6 years from now. So if the father is X, 6 years from now is X plus 6. So whatever age you are now, 6 years from now is an add. So you add 6. 6 years ago means that it's x minus 6. So whatever your age is, you're going to take off 6. Ago means you subtract 6, as in what was your age. So from now you add 6. Ago you subtract 6. The other's age is half the father's age. So half. Father's age is x, so it's a half x. Number 2, the number of cents in each. So if you have x dimes, therefore dimes is 10, so you have 10 times x as the number of cents. So if you have 2 times, you have 2 times 10 is 20, so it's 10x. N quarters, so quarters is 25, so that's 25n. And we'll add nickels. So nickels is 5 cents, so it's 5 times the number of nickels. And if you want to simplify that, that becomes 30n plus 20 if you want to simplify it. Again, n quarters, there's 25 cents in a quarter, so it's 25n. Nickels got 5 cents, it's 5 times the number of nickels. And there it is simplified. X is the number of nickels, and the number of quarters is twice the number of nickels. Triple the number of nickels. The number of quarters, so is triple the number of nickels. So if nickels is X, triple the number of nickels, so that's 3x. So number of cents is 3x. That's the number of quarters, and each quarter got 25 cents. So we have 75x. Again, repeat, the number of quarters is triple the nickels, so that's 3x. And if that's quarters, you multiply by 25. N dollars plus n nickels. So if you got n dollars, so dollars is 100 cents, so it's 100n, plus n nickels. Nickels is 5, so it's 5n. And if you add, you got 105n as the number of cents. Let's continue. Write an algebraic expression for distance in terms of time. Remember, distance is equal to rate times time. So distance is in terms of x. So if the rate, that's r, is 120 kilometers per hour for x hours, so it's 120 times x. If you multiply, the hours cancels out and you get kilometers. That's 120x kilometers. Remember, distance is rate times time. So there's the rate multiplied by time, so you get 120x. B, the speed of truck A is x miles per hour. The speed of truck B is 10 miles an hour faster than truck B. Truck A drove for 8 hours. Truck B drove 2 hours less than truck A. Find the distance driven by both trucks. Well, let's call this truck A, and we'll call this truck B, and we'll say this is the speed, and this is the time. So truck A is X miles per hour. Truck B is 10 faster, so that's X plus 10. Truck A drove for 8 hours, so the time for truck A is 8 hours. And truck B is 2 hours less than A, so 2 hours less. 8 minus 2 is 6. So the distance traveled by both of them, truck A is rate times time, so that's 8x. Truck B is rate times time is 6 times x plus 10. So that's 8x. Multiply 6 times x, 6 times 10. So that gives us 14x plus 60 if you simplify it. Number 4. N represents a smaller number. The larger number is 12 more than, I left off the then there, more than the smaller number. Write an algebraic expression in simplified form for the sum of the numbers. So the smaller number is n, the larger number is 12 more than the smaller. So if the smaller number is n, then the larger number, we're going to call L, is 12 more. So it's n plus 12. And their sum is n plus n add 12. So it's 2n plus 12. Okay, let's continue in more expressions. Let n be the first of many consecutive integers. So many consecutive integers could be 1 plus 2 plus 3 plus 4, or it could be 6 plus 7 plus 8. They just follow each other. So if you have an integer, let's say 5, the next one is 6, the next one is 7, and so on. So if you do that, if this is the first one, then that's the second, the third, and that's the fourth. So write an algebraic expression for each, the fourth integer. So if this one is n, this one is n plus 1, next one is n plus 2, next one is n plus 3, so on. So the fourth one, that's the first, second, third, fourth. So it's n plus 3. The sum of the second, well, the second is the first. Second one is n plus 1. Sum is add. Add on third, which is n plus 2. So that's 2n plus 3 is the sum of the two of them. 10 times the fifth. So 10 times first, second, third, fourth, fifth. So the fifth is n plus 4. So that's 10n plus 40 if you simplify them. Again, consecutive. First, you add on 1, you add on 2, you add on 3. Notice, 5 add on 1 is 6. If you take 5 and add on 2, you get 7. Take 5 and add on 3, you get 8. So consecutive is n plus 1, n plus 2, n plus 3. Number 6, let n be an odd integer. Write an algebraic expression for each. So n is odd. So let's just look at an odd. 7, 9. But if you just do this, let's write consecutive and see what we're, just have a look at. So if we do consecutive, we have an n plus 1, n plus 2, n plus 3, n plus 4, etc. If we do odd, we have an n, then it's n plus 2. N plus, so if that's n plus 1, that's n plus 2, that's n plus, they're consecutive now. So the next even one. So if n is odd, right here, the next even one is add 1. The next odd one after that first one, So you have to add 2. So most times you get consecutive odd. This consecutive odd is n plus 2, n plus 4. Even if you have even numbers, let's say you have even numbers like 4, 6, 8. Consecutive, that's n. So if they're consecutive even, you have to add 2 and add 4. If they're consecutive odd, you still have to add n plus 2, n plus 4. So notice 7 add on 2 is 9, add on, so 7 add on 4 is 11. So these two expressions are the same for consecutive even and consecutive odd. C, the sum of twice the second integer and the third odd integer. Sum of twice the second odd integer. So the second odd integer is n plus 2. And the third odd integer is n plus 4. So that's 2n plus 6. Again, consecutive odd or even makes no difference. It's n plus 2, n plus 4. And I write down some numbers to check it out. So that's the second one, and that's the third one. And there's the simplified form. Triple the third even integer less 4. The third even integer. So it's n, first, second, third. So it's triple the third one, which is n plus 4, less 4. So that's 3n plus 12 less 4. So 3n plus 8. Again, odd or even makes no difference. If they're consecutive, it's n plus 2, n plus 4. If they're consecutive, they're n plus 1, n plus 2, n plus 3, n plus 4, etc. And we have another one based on the angle complementary supplementary. Let x be the measure of angle A. This is the symbol for angle A. Write an algebraic expression simplified for each. The complement of angle A. Complement means the sum. The sum is 90. So if you have two angles that add up to 90, and one is x, then the other one must be 90 minus x. So if you got an angle which is 60, then its complement is 90 minus 60, which is 30, because 60 and 30 make 90. Supplementary angles have a sum of 180. So if one angle is x, the other one is 180 degrees minus x. So if you got an angle of 70, then the supplement is 110. 180 minus 70 is 110. C, twice the complement of angle A plus the supplement of 120. The complement of angle A, twice the complement is 90 minus x, plus the supplement of 60. So 180 minus 120 is 60. So plus the supplement. So the supplement of 180 is 60. So that's 180 minus 2x plus 60. So that simplifies to negative 2x plus 240 degrees. Twice the complement plus the supplement. The supplement is 60. Now, D, the supplement of A decreased by the complement of 50. The supplement of A. So A is x. So the supplement of A is 180 minus x decreased by the complement of 50. Complement is 90 minus 50. So the complement of 50 is 40, because 50 and 40 adds up to 90. So it's minus 40. Again, I could have degree symbols here. So that's, you could have negative x, 180 minus 40 is 140. And again, you could have a degree there. So it's negative x plus 140. We write it down with x first. So that's another review of linear expressions, writing linear expressions. And again, if you like my video, click on the like button, click on the subscribe button. And I'd like to thank you for viewing my video, and I hope that they are helping you. Bye-bye.